Welcome back, everybody. Going on our next lesson in our polygon chapter, we're going to talk about a specific type of polygon, parallelograms. Okay, now a parallelogram is still a polygon, meaning that all the properties, all the different formulas and theorems we looked at in the last section still apply to parallelograms. What we're going to do with parallelograms is look at some properties specific to them. Okay, objective to use relationships among the sides, angles, and diagonals of parallelograms. Let's get going with that. So first off, let's remind you what we mean when we say parallelogram. I'm going to say a parallelogram is a quadrilateral, so four-sided shape, with both pairs of opposite sides parallel. Okay, so for example here, ABCD is a parallelogram because the top and bottom sides, AB and DC, are parallel, and I can tell that from the picture since they both have a single arrow on them. And the same thing, the other set of opposite sides, AD and BC, on the left and right are parallel as well. And I can tell that because they're both marked with two arrows. Okay, so that's what we're dealing with here today, parallelograms. So what we're going to do next is give you those properties of parallelograms, okay, give you some theorems about them, and then we'll go through the rest of the class using those properties to figure out stuff about their sides and angles, and diagonals as well, I suppose. Okay, so each of these theorems are going to start off with if a quadrilateral is a parallelogram, then we'll have something. Okay, for the first one, it's going to be then opposite sides are congruent. Okay, so if we have a parallelogram with opposite sides parallel, I also know that opposite sides are congruent to each other as well. Second theorem, once again, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if the opposite sides are parallel, then consecutive angles, as in angles next to each other, like AB, are going to be equal to 180. Measure of angle A plus the measure of angle B equals 180. We'd say they're supplementary. Same thing with B plus C will be 180. C plus D will be 180. D plus A will be 180 as well. Okay, so consecutive angles are supplementary in a parallelogram. Next up, we'll talk about opposite angles. I'm going to say if a quadrilateral is a parallelogram, then its opposite angles are congruent. So in this case, if we have a parallelogram, then angles A and C will be congruent to each other. Same thing with angles B and D will be congruent. Okay, both sets of opposite angles will be congruent. And then last one, we'll talk about the diagonals of a parallelogram. We'll say if a quadrilateral is a parallelogram, then its diagonals bisect each other. So as in, if I draw a diagonal from one corner of the parallelogram to the other, as in segment AC, we'd say it is bisected if it's split into two congruent parts. So AE is congruent to EC. And then that diagonal also bisects the other diagonal. BE is congruent to ED. Okay, just to summarize those or review them here real quick. If we have a parallelogram, we know opposite sides are congruent. Consecutive angles are supplementary. Opposite angles are congruent. And then the diagonals bisect each other. So let's go ahead and start using these theorems. Okay, problem 1 says, what are the measures of angles 1 and 2 in the parallelogram? So we're given a shape, we're told it's a parallelogram. I know one of the angles, and I want to figure out two of the other ones. Okay, we can actually do these two angles in either order, but we'll start with one just because it's number 1. Notice number 1 is consecutive with the 75 we're given. Okay, it's an angle kind of in a row. We just gave you a theorem ago that said consecutive angles are supplementary, so they'll add to 180 degrees. So if I want to find angle 1 here, what I'll do is I'll take 180 and subtract the 75, which will give me a 105 for angle 1. Okay, because consecutive angles are supplementary. Let's do angle 2 next. And angle 2 is opposite to the 75 we're given initially. And we said a minute ago also that opposite angles in a parallelogram are congruent to each other. Okay, therefore angle 2 is just 75 degrees as well. All right, that's how we can use our two theorems about angles in a parallelogram, okay, to find the missing angles. Problem B is the same idea. why don't you take a minute, pause the video, work through problem B, and then hit play to check your answer. All right, so in part B, we've got the same idea. This time we just want to figure out what angles 1, 2, and 3 are equal to. Okay, so let's start off with angle 1. It is consecutive with this 112. So once again, I have a pair of supplementary angles. Angle 1 will just be 180 minus the 112, which will give me a 68 degrees. Okay, next up, angle 2. Angle 2 is opposite the 112, so I know that those two angles will be congruent. And then for angle 3, there's a couple ways we can think about it. It is opposite angle 1, so I know those two angles will be congruent. Okay, it is also consecutive with the 112, so it'll be supplementary to the 112, or I guess we could say it's consecutive with angle 2 as well. Okay, either way we'll end up with angle 1 being 68 degrees. All right, next question we're going to look at is going to bring some algebra into the mix. So, problem 2, part A says solve for x and y in the parallelogram. And it looks like all of our expressions deal with the side lengths of this parallelogram, PQ, RS. Now, the one theorem we know about side lengths is that opposite sides are congruent, meaning that top will be congruent to bottom, left side will be congruent to the right side. So as far as equations I can set up then, is I can say the top is equal to the bottom. We can say 3x minus 5 equals 2x plus 1. Okay, I'll solve this in a minute. Now, there's another equation I'm going to need because I also want to know what y is. And if I have two variables, I'm going to need at least two equations, or I need two equations. Okay, I need a system of equations. So we'll set that up as well. We can also say that x plus 2 is equal to y. And once I solve these two equations, I'll have a solution for both my x and my y. Now, as far as which one I should start with, I'm going to say start off with the equation with only x's in it first, with the 3x minus 5 equals 2x plus 1. Okay, if I started with my green equation here, it has both an x and a y in it. I couldn't actually solve that for either variable. I need to solve for x first, and I can substitute it in to find the y. Okay, so let's go ahead and do that. I'm going to subtract 2x from both sides, which gives me an x minus 5 is equal to 1. Then we'll add 5 to both sides, which leaves me with x equals 6. Okay, there's half my solution. There's my x. To get the y, then what I'll do is I'll substitute that in for this x in the second equation. So we can rewrite it as, instead of x plus 2, we can say 6 plus 2 is equal to y. Or in other words, 8 equals y, or y equals 8, I suppose we could say. All right, so there's both my variables, both my solutions to this problem here. Let's run through another one together to give you another chance to kind of see a system of equations solved. So part B, again, solve for x and y in the parallelogram. And now notice this time it looks like our expressions deal with the angles of the parallelogram. So for equations we can set up, we can use the fact that opposite angles are congruent. So I know that angle B will be congruent to angle D, meaning that I can say that 2x minus 10 is equal to y plus 20. Now again, I have an equation with two different variables in it. I can't solve this for a variable yet. That's where I need my system of equations. And as far as setting up a second equation, I'm going to have to use consecutive angles. And I have a few options for doing that. I could say that A and B are consecutive. Okay, so they add to 180. Or I could say that A and D are consecutive and add to 180. Now, as far as which one to pick, I'm going to go with the A and B, because notice both these expressions only have an x in them. That's going to give me an equation I can solve for x, and then I can use that to get the y. It'll help me avoid some different kind of more tricky substitutions here. So using the A and B, I'm going to say that 2x plus 10 plus 2x minus 10 is equal to 180. And again, the reason I'm going to pick this equation to start with is it only has x's in it, so we can solve that for x and get x by itself. To do that, I'm going to combine like terms. We've got a 2x and a 2x, which is a 4x. And then the positive 10 and negative 10 will cancel out here. So we have 4x equals 180. And then solving that, I'll divide both sides by 4 to end up with x is equal to 45. All right, so there's half of my solution. And then once again, to get the y, I'll take this x and substitute it into my other equation with the y in it. So I could rewrite this as 2 times 45 minus 10 is equal to y plus 20. So in other words, 2 times 45, which is 90, minus 10 would be 80, is equal to y plus 20. And then subtract 20 from both sides. We end up with y is equal to 60. Okay, so there's another example of using a system of equations to solve for basically variables involving a parallelogram. Part C is the same idea, kinda. You're going to need a system, but it deals with the diagonals. Okay, remember, diagonals of a parallelogram bisect each other. Once you pause the video, try to work through part B, try to set up that system and solve it, and then hit play to check your answer. All right, let's run through part C together here. Again, solving for x and y. This time my expressions are dealing with the diagonals of the parallelogram. And we know that the diagonals bisect each other, meaning that ST will be congruent to TQ, and then also that PT will be congruent to TR. So setting up equations then, I can say that x plus 1 is equal to 2x minus 3. And it looks like I'll be able to start with that one and solve it for x. And then once I have that, I can solve my other equation, which will be 3y minus 7 is equal to 2x. All right, so let's go ahead and solve the equation with only the x's first. I'm going to subtract x from both sides, which gives me a 1 is equal to x minus 3. And then add 3 to both sides. We get x equals 4. And then to finish it off, we'll substitute in the x here to the second equation, which gives me 3y minus 7 is equal to 2 times my x4. So in other words, 3y minus 7 is equal to 8. I can add 7 to both sides of that. Divide both sides by 3. And as we run out of room, we end up with y is equal to a 5. All right, so there's my 2 solutions to this one here. Now, the last thing we're going to look at today is determining whether or not a quadrilateral is a parallelogram. And for that, we'll use the same 4 properties we already gave you. Okay, parallelograms have both sets of opposite sides congruent. Parallelograms have both sets of opposite angles congruent. All their consecutive angles are supplementary, and their diagonals bisect each other. Okay, what we're going to do with this example is add kind of a 5th property that we'll use just for proving they're congruent. We're going to say that if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Okay, so for example, in our image down here, we have BC and AD, a set of opposite sides that are marked both parallel to each other with the arrow and congruent with the tick mark through it. Okay, we'll say that's enough to prove that this is a parallelogram. So in problem 3, we want to know, can you prove that each quadrilateral is a parallelogram based on the given information? Well, let's take a look for each of these. Part A, I'm going to say yes. Yes, because my opposite sides here are both congruent to each other. They both have a length of 5. And then I also know that A, B, and DC are parallel to each other because notice angle A and angle D are supplementary. They both add to 180. Therefore, I have same side interior angles that are supplementary. That's going to make the lines that make them up parallel. All right, so I have one set of opposite sides that are both congruent and parallel. The theorem we just gave you said that that's enough to determine that we're looking at a parallelogram. Okay, so that's why that one's yes. Part B, is this a parallelogram? I'm going to say no. Okay, I suppose no, not enough information. We don't know. And the reason for that is we do have two sets of congruent sides, but notice they're not opposite to each other, they're adjacent to each other. Okay, this is actually a kite, which we'll talk more about in the coming lessons, but I can't conclude this is a parallelogram because I don't know that opposite sides are congruent. Okay, going through a couple more of these. C, is this a parallelogram? I'm going to say no, we don't have enough information. Now I do have one set of opposite sides parallel, but for it to be a parallelogram, I'd need the other set to be parallel as well. I do have one set of opposite sides that are congruent, but I need to know that both sides are congruent to be a parallelogram. Now, if I had the same set of sides that was both parallel and congruent, then it would work. That'd be like example A, but these are different sides. Okay, that's why I'd say no. That's why I'd say not enough information. Okay, D, the last one. Looks like this one deals with angles. I'm going to say yes for this one. Yes, because it looks like L and N, a set of opposite angles, are congruent. And I know that because they're both made up of the same two congruent angles, the single arch angle and the double arch angle. And now with this one, I also need to know if the other set of opposite angles are congruent, A and D. I'm going to say in this case, I do know they're congruent. Why is that? Well, they're congruent by the third angle theorem, which stated that if I have two triangles with two angles congruent, which I have here, the third angle also has to be congruent. Okay, therefore we also have the other set of opposite angles congruent. Both pairs of opposite angles are congruent. So we can say that yes, this is a parallelogram. Okay, I guess the key for this is you need both pairs of opposite angles, just like with the sides. And the trick with this one is that if I didn't have this line here, if this wasn't split into triangles, this actually wouldn't be a question I could do. All right, there you go. That's section 6.2 on parallelograms. Okay, start getting your practice in. Start going to town on the homework. Like usual, let us know if you're getting stuck or you need help. And we'll see you folks for the next lesson.